Problem number 4, we have f of x equal to the quantity 2x plus 1 cubed. G is the inverse of f of 0 is equal to 1. We're asked to find g prime of 1. Alright, so we know by the rule for deriving an inverse function, g prime of 1 will be equal to 1 over f prime of g of 1. So we need to figure out what g of 1 is because that was not given to us. What was given to us is that f of 0 is equal to 1. We know, since g and f are inverses, that if f of 0 is 1, then g of 1 must be equal to 0. Okay, that is the definition for inverse functions. So this means that we're really interested in 1 over f prime of 0, since g of 1 is equal to 0. Well, we need to find the derivative of f then. So f of x is equal to the quantity 2x plus 1 cubed. We have to derive this, and we have to use the chain rule because we have an inner function being cubed. So chain rule says derive the outer function, which means we have 3 and then squared, right? Because the 3 comes down out front and we drop the exponent by 1. And we keep the inner function, 2x plus 1, and then we multiply that by the derivative of the inner function. And the derivative of 2x plus 1 is 2. That's f prime of x. We want f prime of 0. When we plug in 0, we have 3 times 0 plus 1 is 1. So 3 times 1 squared times 2. 3 times 2 is 6. So f prime of 0 is 6. So we have 1 over 6. And our answer is D. For number 5, we have f and g are differentiable, and we see that f of g is x and g of f is x. Okay, so this is just another way of saying that f and g are inverses. Okay, and we are trying to figure out what g of 8 and g prime of 8 are equal to. We're told that f of 3 is 8, so just like the previous problem, if f of 3 is 8, then g of 8 is equal to 3. Okay, so that immediately eliminates A and B as answers. Right. We also need to find g prime of 8. Well, by definition, g prime of 8 is equal to 1 over f prime of g of 8. We know that g of 8 is 3, so it's equal to 1 over f prime of 3. And f prime of 3, we're told, is equal to 9. So we have 1 over 9. So g of 8 is 3, g prime of 8 is 1/9. So our answer is E. Number 6, we have f of x is the inverse cosine of x squared. What's f prime of x? So we have to have all of your inverse trig functions memorized. Right? Inverse cosine, right, the derivative of arc cosine in just of x is -1 over the square root of 1 minus x squared. Okay. This is the arc cosine of x squared, so we're doing a chain rule here. So the chain rule says derive the outer function. The derivative of arc cosine is this template right here. So we're going to have -1 over square root 1 minus. Right, same template as what we see up here. But it's not going to be x squared because we have x squared here because we have arc cosine x. Here we have arc cosine of x squared, so we're going to have x squared squared. Okay, so that's keeping the inner function. So we derive the outer function, we keep the inner function, and then we multiply by the derivative of the inner function. And the derivative of x squared is 2x. So we have to make this answer look like one of these 5. Well, the 2x on the after the fraction can go up into the numerator, so now we need a -2x up top, which right away tells us that our answer is B. But just to verify that, we also know that x squared squared, we multiply the exponents, and that is in fact why we have 1 over x to the 4th underneath the radical. Problem number 7, inverse sine of x is equal to the natural log of y. What's dy dx? This is implicit differentiation. All right, so inverse sine derives to 1 over square root 1 minus x squared equals, and now we derive the natural log of y. Well, the natural log of x is 1 over x, so the natural log of y will be 1 over y. But because we derived a y term, we multiply this by dy dx. Now our goal is to get dy dx all by itself. How do we do that? We just multiply the right side by y. That will eliminate these. But if we multiply the right side by y, we have to multiply the left side by y. So we want y over the square root of 1 minus x squared. A is your answer.